This will be a high-level overview of the AMC 10, and we're going to go page by page. Let's review how the AMC is scored. Students get 6 points for each correct answer, and then 1.5 points for each answer left blank, and no points for wrong answers. Page by page, the problems get harder as you go along. The first 5 problems will be the easiest on the exam, and they get harder as you go through the exam until you get to the last 5 problems, which are known as the final 5, which are the most challenging problems on the exam. Let's take a look at some sample tests. Here are the first 5 problems from 3 recent AMC 10s. The first problem of pretty much any AMC 10 is going to be a straightforward pre-algebra problem. Looking at the rest of the problems, we see that on this exam, there are 2 more pre-algebra problems. Number 2, for these 2 exams, I would categorize as elementary geometry, finding the area in a plane. This number 3 is more of a 3D geometry problem. Over here at number 2 and at this exam, number 4, I would call these elementary algebra. Over here at number 3 and down here at number 5, these are elementary number theory problems. We've got a rate problem over here and over here. And this last one tests how well you can calculate averages and use the average formula. Let's see what your score is if you're only able to answer these first 5 problems. You'll get 6 points for each of these 5 problems. And if you leave the rest of the exam blank, that's 20 more problems. This earns you 60 points. That's an okay score. I don't know that it rises to the level that you would want to report this on your college applications. If you're unsure, talk to a college counselor about this score. Let's go on to page 2. Here are the next 5 problems on 3 recent AMC 10s. I'm going to circle some number theory problems. We have one here, here, and here. There's one down here. And we've got a place value number theory problem over here. Most of these go beyond plugging into simple formulas and require you to do something novel. For example, in this problem over here, they define a particular type of number that you will not have seen in the past, and you have to be able to logic your way through. Here we have a rate problem. Over here we have some geometry with some angle chasing. We don't see this too often. This is a fence post problem. We actually have a logic problem over here and one down here. Here's an elementary probability problem. I guess I would categorize this as pre-algebra. I'm not really sure. This one tests your ability to factor, and in particular, this one tests your knowledge of difference of squares and also what we call wishful thinking. And finally over here, we've got some intermediate level algebra to solve number 10. Let's calculate your score if you're able to answer all the first 10 problems. So you'll get 6 points for each of these. And if you leave the rest of them blank, that's 1.5 points for the remaining 15 problems. This gives you a score of 81.5. I would call this a respectable score. It's usually not going to give you an Amy qual, but if you have earned some other achievement in a STEM field outside of math and math contests, then you might want to include this on your college applications. But again, check with a college counselor who is familiar with math contests. Let's go on to the 3rd page. In this exam, problem 11 was a more challenging rate problem. Number 11 deals with a regular hexagon. These hexagons you should really know inside and out because they come up all the time on the AMC. This problem here, again, is pretty basic number theory. You really want to be familiar with numbers in different bases other than base 10. If you can do that, you're going to pick up some easy points here. Here's another number theory problem in base 9. This one is a factoring problem. You can also solve using guess and check. Might be faster that way. This one looks like a volume problem. You definitely want to be familiar with the volume of a cone. And actually, an easier way to solve this is using logic. Here's another problem that's pretty challenging to find the volume of a tetrahedron. This comes up a fair bit, so you want to be familiar with tetrahedrons. I thought this one was a pretty easy probability problem. I thought this number 14, also probability, but I thought it was more challenging. 13 is a really typical problem. You want to make sure you've had a lot of practice with similar triangles. You also want to make sure that you know how to graph conic sections like this parabola, and also be comfortable with absolute value problems. Down here at this number 14 is a Vietas for a higher order polynomial. You'll see a lot of circles that are tangent to lines. I also want to point out that a lot of these geometry problems now are not going to have diagrams accompanying them. You'll have to draw them yourself. Again, with this number 15, we have more similar and congruent triangles. So look out for those, especially in right triangles. And here again, you'll want to be able to graph parabolas. Let's check your score if you can correctly solve the first 15 problems. The good news is that if you can correctly solve these first 15 problems, this is almost always going to get you a qualification for the AMC. This is a great thing to have on your college application, but keep in mind that every year there are about 7,000 AMC qualifiers, and they're not all going to get into the top colleges. So you want to have some sort of achievement in another area if you're aiming for these top schools. But an AMC qualification is a really terrific achievement, and you're in an elite group of students. Let's go on to the next page. If you've been able to correctly answer most of the first 15 problems, you'll want to start to be a little more picky about the problems that you can solve, because you're probably running low on time, and some of these problems will be much easier for you than others. It's probably worth your while to familiarize yourself with the floor function. Here it's combined with the absolute value. This is a more intermediate counting problem. This is also a counting problem. It looks pretty easy because there's only 4 crops that you need to distribute in these 4, but I also thought it was kind of confusing to get the counting right. This number 20 down here is also a more advanced counting. It involves casework and the principle of inclusion and exclusion. Here we have an advanced probability problem. You'll need Bayes' theorem to solve this. This looks like a statistics problem, but I would also call this a counting problem. We see again up here another regular hexagon, but there's this additional 3D aspect to it that makes it challenging. Here is another 2D geometry problem. No diagram, so you'll have to draw your own. You'll also need to draw new lines that aren't explicitly defined in the problem statement. And you'll need to use a variety of geometry techniques to solve. Over here, we're doing some transformations of lines, but this is pretty advanced. Here again, we have some 2D geometry in number 18. There's a lot of symmetry, but it's hard to figure out the best way to find this area. And here's another area problem. I found this one to be pretty time-consuming, although it is fairly straightforward. Here's another number theory problem where you're trying to find the leading digits. I've not seen a problem like this before. But over here, again, we see another conic section, a circle, and absolute values. I actually see this combination a lot on the AMCs. Over here, we have some functional equations where you have to figure out for yourself what is the definition of the function. And down here with number 20, you need to be familiar with the discriminant of a quadratic equation and be comfortable with some basic casework. So if you've already solved a lot of problems, be fairly selective with this next set of 5. You should be able to pick out a few doable problems and add to your score if you need to. Now let's go on to the final 5. Use a lot of caution when solving final 5 problems. Remember, you get no points for wrong answers. Also, these problems tend to be more time-consuming, so your time might be better spent going back and checking your answers to make sure everything that you answer is absolutely correct. If you've done that and you have some time, let's see if we can pick out a few of the final 5 that are doable within your remaining time. This one I thought was pretty doable if you've had some advanced counting and can identify some shortcuts along the way. Otherwise, I thought there was a high risk of error if you cancel factors incorrectly. This I actually thought was a pretty easy counting problem. If you start with 2 polygons at a time, you might be able to see a pattern. I personally don't like problems where you have to do things like color edges of a cube or a pentagon in this case. Here we're labeling edges with either 0 or 1 and counting the number of ways of doing that. Here again, we're counting the number of ways of coloring these unit cubes. And here's another example down here. So if you like this sort of counting, you're in luck. There's probably going to be one on your AMC in the final 5. I actually thought this one was really doable. It's another hexagon, but since it's equiangular, you end up with a lot of congruent lengths. So I personally would jump on this problem. Over here again, we have another cone, but it's one of those 3D problems that can be replaced with a 2D problem by taking a cross section. And then the spheres turn into circles that are tangent, so it ends up being a straightforward 2D geometry problem, although it is also time-consuming. When you see a problem that asks about divisibility, it's often going to concern mods. Mods are pretty fun and easy to deploy, but in this case, I found this problem to be pretty hard nonetheless. I personally thought this number 22 was a kind of nightmare. algebra problem, time-consuming, easy to use the wrong formula. Over here, this seems like a straightforward number theory problem, but it turns out it's also pretty time-consuming. I personally would jump on this number 23 because it's only a 3x3 grid and there's a lot of symmetry, and I just didn't think this was really hard to count. This 24 I would also classify as a nightmare. Lots of algebra going on, lots of different formulas to deploy. This one, also a nightmare. It's probably doable if you have a lot of time, but you have to draw these perpendiculars and figure out which of the right triangles are similar and congruent. So maybe not so bad. This one is probably easiest to solve if you know the shoelace theorem. This doesn't come up very much. So that's my overview of the AMC 10. Good luck. If you'd like me to solve any math contest problems, please leave them in the comments.